The last video, we have learned that coefficient of thermal expansion is the fractional changes in the length due to the changes in the temperature. So, our coefficient of thermal coefficient our coefficient of thermal expansion is the delta L by L by delta T. Delta L by L by delta T. And the unit of the coefficient of thermal expansion is per degree Celsius. So here we do not have any unit because this part is corresponding to strain and it do not have any unit. So coefficient of thermal expansion will be per unit changes. Okay. Now to solve this problem, where we need to consider uniform temperature rises from room temperature 25 degrees Celsius to 50 degrees Celsius, and we have to determine axial reaction developing the structure. So here the uniform temperature rises means throughout the member, the temperatures rises from 25 degrees Celsius to 50 degrees Celsius, and if there is a uniform temperature rises, then the member there will be only axial forces. Now here we have to identify, we have to calculate how much axial force is developing the structure. Now here you just see, we know the strain quantity is your delta L by L. So here if you consider here, delta L by L is coming alpha times delta T. So this part is your strain, and we know the stress is your E times epsilon. From there we can identify the stress. The stress is equal to E times alpha times delta T. Now once you know how much stress is acting, then we can identify how much axial force is developing. The axial force will be stress times the area, multiply with the area, we can identify the axial force. Okay. So the equation for the axial force will be AE alpha times delta T. So delta T is basically Ej minus Ti. So this axial force basically will create support reaction. This axial force will basically create support reaction. So here from this equation we can calculate how much axial force or how much axial reaction is developing the system. Okay, so here A is your 10 into the power minus 3 meters square. Alpha is your 12 into 10 to the power minus 6 per degree Celsius. Young modulus is 200 GPa, so it is basically a still member. So here, if you put the value A, E, alpha, and delta T will be your 25 degrees Celsius. You can identify the axial forces here. So the unit of the axial force will be the Newton because all the units are in meter square. Here you can see 200 GPa. So basically 200 GPa means 10 to the power 9 Pascal. So 9 Pascal means Newton per meter square. Area is also given in meter square. And alpha is per degree Celsius. And here we have the changes in the temperature, that is degree Celsius. That is going to cancel out. At the end, we will have a axial force that is here in Newton. Okay. So we calculate, we will observe that is here 6.4 Newton force is developing the center. Okay. Next, we are going to discuss if there is a non-uniform temperature rises. For example, at the bottom we have 50 degrees Celsius, at the top we have 25 degrees Celsius, and initial temperature is 20 degrees Celsius. Then how much temperature and how much axial force is developing and how much bending moment is developing in the systems. And we also can calculate if the temperature rises, how much deformation is occurring in the system. That's what we are going to discuss in the next video.